Welcome, everyone. Good evening. Everyone can hear me. Nice. How is our weekend going? Hope you're having fun while learning too, really. Awesome. Yeah, I'm cool too. We're just taking it easy one step at a time. Uh, yeah, let's see. So, from our last class, where we tried to do something very small and simple, uh, are there parts? I mean, we able to go through go through the last class's mini project. And what are our thoughts? Hi, welcome, Francis. Welcome, Chichuku Kanji. Yeah, welcome, Kingsley. Uh, so, have we been able to go through? Do you have any questions from that? Okay, we're supposed to have started object-oriented programming, but as we don't have it on our LMS yet, I didn't want to dive into it so I don't get many of us confused. But we might definitely just need to just go ahead and get started with it. I think looking at other topics that we're supposed to have covered, we pretty much talked about all the other ones supposed to have covered. So yeah, we might just dive into object-oriented programming so we don't waste any more time. Let's see. Yeah, good evening. Adeni. This first time I'm seeing Adeni. I have you been joining the class? Like, have you been joining the previous classes? This first time I'm seeing that name. Or could it be that you just added a new picture? Yeah, maybe. Hello, Kenichi. You're welcome. Okay, we have a good number of people around now. So let's just get started. So OOP, object-oriented programming. Yeah, object-oriented programming. Basically, it's a programming style that's existed for like years, and basically, it's the idea is to build entities of your program as objects that can, hold states and also have functionalities like functions that you carry out. Okay, so basically, it's like having an object, and then for every object you have, basically those objects have a particular state, and they have functions that they can carry out. So anything can be an object basically. So far you can model it to have states and have functionalities that it can carry out. For example, a person, a person can have things like states like complexion, uh, height, and then functionalities that a person can carry out can involve things like a person can walk, a person can. Hope everyone can hear me clearly. A person can walk, a person can talk, a person can eat, sleep, wake up, and move around, and all those kind of things. So basically, when we talk about object-oriented programming, we are trying is just a means of us modeling entities in our program as objects, like making sure that they are like one single object. We classify them as objects, and then the list of things that you can or actions you can perform on them are defined as methods. In Go, as usual, in its own style, it has a different way of reasoning about object-oriented programming. It was never meant to be an object-oriented programming language, but with the ways where it's being implemented and all that, we could easily see similarities between it and other languages that call themselves object-oriented programming languages. The only thing is that it has some aspects of object-oriented programming that it's dropped, it abandoned, and didn't use. Okay, things like inheritance, sorry, inheritance and picking composition over inheritance. The way it defines is private and publicly accessible entities and all that stuff. So we'll be looking at all that. Basically, up to this point now, you can actually write an effective Go program. At least we did that in the last class, okay? Uh, Based on all the fundamental concepts that we've treated so far for about a month now or so. Uh, so there are some aspects of object-oriented programming. Can you hear me? Someone said they can't hear anything. Let's see. Can everyone hear me? Okay. Oh, great, great. Okay, try and fix up your audio setup maybe to help. So when you talk about object-oriented programming, just like I was trying to say, It basically means setting up the entities in your program as objects. Now, what's an object basically in a program? An object is something that has state and has functionalities that can either update that state or you know display that state or change that state. Let's just put it that way. An object is something that okay. I am seeing new faces today. An object is something that has state and then has methods or functions that can update that state. Okay. And in Go, like I said, Go didn't use general OOP paradigms that we know from other languages. Okay, and that's why it's quite simple to pick up. Its own idea of OOP, we're just picking up simple things and uh, just expanding on those things. Okay, so we're just going to dive right in and start coding something. If you have any questions, just let me know so that we can easily get the concept fast enough. Okay, so we'll start from the methods. We have been talking about functions all through this while, but now when you are within the OOP, I'll just shorten it to OOP. When you are within the OOP space, you don't talk about functions again. Functions now become methods. So basically, all methods are functions, but not all functions are methods. So methods are called methods because they've been attached to a particular, for instance, class now. Okay. So that's why we call them methods. And the way we attach them in Go, because Go doesn't have anything like class keyword, it doesn't have anything like those kind of things. It doesn't have it. Because using the class keyword is how we basically, sorry guys, give me 1 second. Yeah, sorry, I had to adjust my seat. So using the class keyword is how we always define the scope of a class in other OOP languages. So in those other OOP languages, there's something we always call a class, and then there are the blueprints from those classes. When you instantiate those classes, when you create a new item from those classes, that's why we call them objects. Okay, so objects are like creations of a class. Okay, we don't have the luxury of using another language here to explain this, but I really want us to all get this. Let me see. So I'm just going to share my screen now. Yeah, good evening. I'm going to share my screen. Yeah. Okay. Okay. So I wanted us to understand. For some of us that are coming from other languages, you probably understand this concept better than others. But nevertheless, I still want to show us, in case you see it in other places, the concept of what a class is. So before you can call something an object, it must have existed as there must be a, let's call it blueprint for it. Okay, you understand what I mean by blueprint? Blueprint is basically the outline of what something you want to create, the outline, what it looks like on paper. So basically, a class is like a blueprint, and then from that blueprint is where we create multiple or countless, objects of that exact blueprint. Let's take for instance, we have something like a. Have you also my screen? Class car, for instance. I'm just using this as explanation. You will see that the keyword, you will see that class is not highlighted like other things, like if I say type, see it's not. You see the highlighting doesn't. It's not showing on class. That's because there's nothing like class, concept of class in Go. Are we together? So basically, I'm trying to create a blueprint now. So I think I should do this on a new file. Sorry. CD dot. Yeah. Okay. Yeah. We write the number of classes. So this should be class 8. So that would be okay. Yeah, let's let this guy open up. Hope we're together, guys. It's getting more interesting, really. What we've done so far in past weeks are just basics of programming in any language, in any struggle type language. So it's getting interesting now. I hope it's getting interesting for everyone as well, because Go is really interesting. So let's create the main file. Okay. And we will have what do you call this? Okay. And basically, we can now start talking about what we want to talk about. So OOP, object-oriented programming, again, it's created from the concept of having blueprints and then objects created from those blueprints. So in other languages, we have things like class, class, car, for instance. Okay. Sorry, 1 second. Now, based on so don't let me use class car. Let's use something else like class automobile. I want to say that we have a class called automobile. And what are the peculiar things to an automobile or a vehicle? Is automobile in general word now? Hey guys, what are the peculiar things to items you call an automobile? Yeah, peculiar things. No, what I'm trying to say is that if you call something automobile, what are the things that are common to it? That are like generic to every automobile. Yeah, tires. Yeah, cars. I would let me see. But I wanted something that's common to all automobiles. Okay, so let's go with automobiles have things like they have tires. So tires. So that be. Let me do this. Tires and yeah, tires, windscreen. All of the wheels have windscreen. Yeah, but something more. I agree with you. Windscreen. Every vehicle of some sort have windscreen. Yeah, brakes. All automobiles have brakes. So let's go with windscreen, brakes. Yeah, what else? Batteries, awesome guys. Okay, batteries, uh, capacity, yeah. We could have something like transmission. Transmission is like, what's the mode of transmission? Is it manual or automatic? What kind of things you get? We could have things like, most important, the very important one is the engine. Like anything that's like an automobile as an engine. Okay, let's stop here. Okay, let's stop here. I will see that we're beginning to form the blueprint, right? We're beginning to form the layout, the blueprint of it. Let's use the blueprint, and let's just stick to that. Okay. And every automobile will definitely have a variation of all these things. So some may have 3 tires, 4 tires, 6 tires, 12 tires. There are trailers, there are vans, there are cars, there are sports cars, and all those kind of stuff. So you see that most of the attributes we have here are already defining those things in a general way. Okay. So basically, these are what we call states. Okay. These are like states of any automobile. Okay. And now, after all these things, what are the functionalities of or functions that can happen in an automobile, basically? So we have things like can start the engine, right? What other thing? Yeah. I started with that. What other thing do we think an automobile can do? You can start the engine of any automobile, right? So after starting the engine of any automobile, it can uh come on guys. Let's see. You can drive it, exactly. You can accelerate, yeah. Accelerate. You can drive, move it around. Okay. Move it around. You can apply brakes, yeah. So brakes. So because brakes here is also similar to brake here, we need to find a more descriptive name to give it, exactly. Reverse. Awesome. But reverse can fall under drive. Do you agree? Onukaji, do you agree that reverse falls under drive? I'm just going to put it there as part of, so that I know we are all describing everything we think automobiles can do. So we're putting it there because it's one of the functionalities of an automobile. You get it? It's one of the actions that it can perform. So yeah, reverse is like an attribute of drive. So you just need to, for drive, for instance, we can just say, we can pass a boolean variable. A boolean variable, if it is true, go forward. If it is false, go backward. You get that kind of thing. So we'll get to those points where you think about programming in like more higher concepts. Basically, I like that idea. It can reverse. You can apply brake. So what you can call this is apply brakes. In every automobile, you can apply brakes to them. And yeah, we can stop here for now, right? If you put this trying to, yeah, you can park, turn off, start, okay. So we put this at stop, okay. Somebody said park is also. Let me see. I like the ideas that you guys are bringing to park, but I'm seeing it as park. Park can be like also under another parent action like drive. When you're going to park the vehicle, you're going to drive it too, right? But it's just that the speed at which you are driving it will be different from the speed at which you used to park it. Do you get it now? So uh let's have park there. Park. Okay. So Those are like some of the methods we can have. And basically, we've we've uh, we've fleshed out the blueprint of any automobile. If you want to create a car from from this from this blueprint you have created, so what we have here is what we call the blueprint. The blueprint of all automobiles. Okay. Yeah. So this is a blueprint. Now, if you want to start creating objects from it, that's where we now have to, do things like bar. That's why you cannot create a car. Okay, so we say bar car. Don't take. There's no need to just all this down. I'm just trying to explain the concept here. Mm. I'm just trying to explain the way OOP exists in other languages because, like, that's where it started from. Golang is like one of the first people to bring up his own new way of implementing OOP. So you don't really need to take this, just understand the concept behind it. I'm explaining blueprints and then the objects of those blueprints. Okay, so we created an automobile and now we want to create a car from it. Now, by creating this car, that's where we can now call this car this car is now an object. Okay, so you get the idea. That's basically it. So you can create objects. Now, for each object you create, okay, each object you create, you can now specify what all these states should be. If you want to create car now, car has how many tires? 4 tires. Okay, you get that now. So I can say car dot tire TYRES equals to what? Equals to 4. Now I can create another object based off the blueprint, the automobile blueprint. I can call it trailer. Trailer. What's what? New automobile again. Are you getting me now? And then say trailer dot tires. How many tires does the trailer have? 6. Awesome. 6. Can you see it now? And now, because we have created these objects from these two guys, okay, both of them have access to all these functionalities. A trailer can start, a trailer can be driven, a trailer can reverse, a trailer can accelerate, apply brakes, stop, park. Oh, 18. Nice. I really don't know myself, but let's go 18. Okay. So are you seeing the uniqueness of what we're saying now? We created something that looks like a when you go to the bread factory, how many of us have seen where bread is being made before? Like locally made bread, not, I don't know about the bigger ones, but I guess they all follow the same pattern. If you go to some bread factories, there's a container that they use when they want to bake the bread, okay? And that container now determines the kind of bread that everybody is baking, the kind of bread that they make with it. You get that kind of thing. So that's exactly what classes and objects. That's what we're trying to say. Basically, you have something that is the blueprint. Okay, it's like is the blueprint of what you want to make, and then you can be creating multiple objects from it. So this is a car, for instance. We can say, in fact, let's say model. Every automobile will have a model, right? You have a model. Because of that model we've added now, we can now say we can call this car Honda. Are you getting it? And say because the name is Honda now, you now say car dot or no, under, this is under, so under dot name, uh, model is what other models do we have there, please? Somebody help me out here. We have under, we can have a Camry or Toyota now. So we have Toyota, and then it's also an automobile, right? I hope you are getting all this. It's quite like the basics for everything we'll be doing also. Toyota is a brand of car, is an automobile, and then Toyota dot model would be a Camry. We could also have things like year, so that you can say Toyota dot year brought to 2015. And it's awesome. Yeah, cool. Great. Okay. So you see how many objects have we created from the automobile class now? We've created 3. We have Honda, we have Toyota, we have trailer. If we know any, or let's even call these Benz. Those Benz. I wanted to make different. What about it? Bikes too are also automobiles because they have almost all of these parameters except things like windscreen. So we can say windscreen can be a boolean that'll take true or false, so that if it's present for one automobile, we add it. If it's not there, we remove it. Do we agree? Motorcycles, motorbikes are also they also fit into this blueprint that we've created. Okay, so basically, we can create an object of motorcycle or bike. So, which popular bike do we have now? Suzuki, also new automobile. Okay, and Suzuki dot tires, equals to 2. Are we together? Awesome. So these are the foundations of OOP. We are not treating OOP the way it's being done in other languages. So there is really no much to it. We just need to look at the way Golang does it, and then we keep practicing many more examples around. Okay. So I'm going to just incorporate that pattern of us, practicing much and more examples on concepts that we've learned, so that we are retaining it. Okay. So I hope everybody understands what I've done so far. Any questions, please? What I've done so far? We're about to go to the Golang way of doing things now. This explanation, is it simple enough? Do we go over it one more time? Guys, talk to me. Do you have any questions around all that I've explained so far? Hello? Yeah, okay, great. So let's go to Golang's way. Yeah, so I'm going to clear all this. Start all over, package, main. Okay. I am going to start. I think I'm going to use the same example we used before, but I'm going to use something that we can play around with much more. Good. So in Go, because Go is Go really. The way you implement OOP is by attaching functions to existing types. Please just get that. It is by attaching things that are functions. You attach them to existing types, and then they become methods. So we call them methods or receiver functions. Okay? We call them methods or receiver functions. Are we together? And how is that done? Let's take a type, for instance, type gallon, float 64. Or better still, let's use the automobile guide that we've been using before. So we'll say type what? Type automobile. String for now. Okay. Now, look at this. We have form. What do you call it? Form. Empty dot. Are we together? Now, this is a function, but we're talking about OOP now. Now, OOP needs it simply means we need to attach this function and make it. We need to make it a method, right? So to do that, another version of this guy will be func this. That's a receiver to it. A or to move start empty dot ln starting. Are we together? This is a method. This is a function. Okay. Now, you see, we have upgraded this guy, this function, to become a method, and we did that by passing this style into it. You can see the way we defined it. We pass that extra definition into it. Now, work with me here. Basically, that extra definition we passed to it, you can see that we attached it to the type that we have previously created. Okay? That's what makes it a function, a method. Now, this guy that we attached here can also be called method receiver. Method receiver. So the methods can be called methods or receiver functions. Now, because you attach this guy to it, because you attach, this is the function. Look at our function. Our function is still the normal way we've been defining function. Okay, but now we've attached something we call a receiver to it, a method receiver to it. This method receiver identifies who does this guy, who do you belong to. Are we together, please? Like, does that make any sense? I'm going to take it again. We are going to go into deeper examples. Just follow me. Okay. So because we have attached the start function to automobile by doing this, it has become a method. Okay, let me put this one. Let me put start. Let's name this as start2 so it doesn't confuse anybody. And you can see that start2 is still a function. So anybody can call start2 ordinarily. But to call start1, I've renamed this to now, please. To call start1, you have to access it through the automobile type. Are we together, guys? Okay, so that's basically what you need to attach types to it, to attach methods. So in the real sense, this is our class. This is our blueprint. Automobile is our blueprint. It is like our class from the first example I gave or I showed us. Okay, and to create objects from it, all we need to do is to go and say func in. Okay, this is our main function now. Inside func main, you can now create what? Come on, what's it now? You can now create sorry, you can now create an object from it. So that will be Toyota what automobile what's it asking for here? Sorry, equals to let me see string. Now, because we've not completed this guy, that's why it's giving error. But ideally, this is what it should be. Whatever we want to pass into it, we're going to complete it now by building out, the other properties we built out when we were talking about class earlier. Okay. But for now, what we have is this, and when we have start, we can now say return. You can return from here. Return a string, for instance. Okay. Now let's see. FMTV dot Toyota dot start one. I'm wondering why this guy is showing this error. It's not an expression. Yes, I know. Here to review. Yeah, but I'll use a struct now, so that will be better. 1 second. So the idea I'm trying to explain here basically is that you cannot call start1 function, start1 method rather. Take note of the naming now. This is a function. I can call it anyhow. Starting start to function. Okay. And this one is starting. So you cannot call this start1 function without first creating an object of automobile. Okay, so I can't just say start1. I can't do that, but I can do start2. Can you see the differences? And that's because yeah, yeah, I'm going to try that. Let's see. But basically what's going on here is that I can't do start one, but I can do start two. Because start two is a function and start one is a method basically on it. Okay. So I can't like do, I can't call it because it has nothing that is attached to. As start one is here, the compiler doesn't know about it because it hasn't been attached to anybody. Okay. Because it was defined as a receiver function. Receiver function is a function that is being attached to a type that makes it a method. Okay. And so it is that receiver function that the compiler can just, that is that receiver function that the compiler can identify. So it's from identifying that receiver function or the class it belongs to rather. When the compiler sees your class, it will know all the methods that you have on yourself. You get that? Because it cannot see your class, it doesn't know that this guy exists. Okay. Now let's take the example up a bit. I'm going to use some units of like measurements here. Let's see. No. I'm not sure it's because the data is in quotes. Because if we do things like, if we do something like, let's see. I just do units here. This. And I make this unit also. Part of the module here. And I say return from something like tires. No. I'll say something like return. Something like this. And I go up and I come back to my main, okay, and I say Toyota. This is just a very weird example, really. What we used to identify objects is as structs, but it's good that we are here. So review, passing something like one. Okay. You see that it works now, and then I can now call start one. Let's ignore this. And now I can now say fmt dot println Toyota dot what start one. And everything works perfectly using the updates I made. Okay. So the reason why it didn't work earlier was because we didn't sort of like instantiate it with any value. So it doesn't even know when it gets here, it doesn't know what to do. Okay, so if we run this now, we should be getting something like go run. You're getting 4. So you can see the start2 function that I called without any receiver worked normally. So this is the output for my terminal, guys. This is start2. This is what happened. And then for this one here, remember that we returned from this guy. This is start1. From start1 we returned. And when we returned, it gave us 4. So I'm going to explain what happened there in a few bits. But that event, how many of us have heard of this in programming languages like this dot that, this dot that? Yeah, that concept is happening here. So you will see that in action. But we're going to take a very, very cleaner example now. This is just something to show us what we're talking about, the difference between methods and functions. So just note that, like, something is a method, something is a function. They are always very different. Okay. Give me a moment. Give me a second, guys. I'll be right back. Yeah, guys, we're back. Thanks for waiting. So, basically, where were we? We're looking at methods and how they are different from functions, basically. So, you can't call a method ordinarily all by itself. Can everyone hear me, please? All right. Sorry, I had to just put on my chain. So this is not a perfect example. It's not a perfect example for class and object, but it's a way to show you how Go begins to differentiate itself in the way it implements object-oriented paradigms. So methods, like we saw in the previous example that I gave, are always defined inside the class. So you have a class and you put a method inside. But with Go, any function can be a method. You just need to attach what? The method receiver to it. Okay? The method receiver is one that will tell us who should I attach this function to? That's what it's saying. Who should I attach it to? And basically, we created two functions, start one and start two. Okay, and then we made one a method and we left one as a function. Now we will see that start two, this is one we have been using all through the class, like right from the beginning of the class, start two. And you see that you can call it all by itself. But the other guy, start one, is just there attached to this guy. So until you create an instance, until you create an instance of automobile, you can never ever call start one. Do you get it now? Until you create an instance of automobile, you can never ever call start one method, because just like I said in the blueprint explanation, we are creating a blueprint. It's only people that extend from that blueprint that have access to all the methods and from inside that blueprint. Okay, so that's like what's going on here. Uh, so let us look at a very longer example. Okay, we're going to be using a very longer example now. Let's see. So, a better example to explain all this. So we say volumes, group, name. I'm going to start with this type. Float 64. Now, it's something I want to share with us, an image, so that you can understand this example better. Houses. Conversion charts. Yeah, I think I found what I'm looking for. I'm trying to look for a conversion chart for this example that I want to show us, and I think I found it. Awesome. Uh, Let me download it now. Copy image. Should I post it on Slack? Maybe I should. I'm not sure I'm getting a link to it here. Copy link. I'm just using this as an example of what objects are really. So I'm going to post it on Slack. Okay, great. Let's post the image on Slack. Don't get too confused. Let me change my display. It's getting to night mode. Come on, come on, come on. Slack does not want to come up now. Okay, while Slack is loading, let's continue this. Let's continue this. Let's continue this guy. So we are going to be implementing like volumetric system. But most of us may not be familiar with this volumetric system. That's why I'm posting the image. So the image will help you understand the volumetric system we are trying to implement, and then you would understand how we are implementing it. Okay. So just feel free to ask me questions. Golang, paste the image here. Yeah. Okay. Can we all see it now? Posted it. Can we all see the image I posted? Oh, let's do cop. I think it's cop. What I'm seeing here. Okay, cop. After we do this, we'll do the automotive version. This one gives us more room to play around. Like based on methods, the methods that we just treated now, that's what this example is based on. Okay. The OOP and all, we are not doing that implementation now. I hope you get what I'm saying. So I explain methods and then I'm trying to give an example of methods. So something for us to play around, okay? So we have cop. So we have type cop and then this guy. C times. The cop, we can also have an arrow. I'm using that chart I shared, formulate an example of methods, and we'll explain everything. Everything will make sense now in just about a minute. So we're having one-liner functions. Some people say Golang is getting staged now actually, but really it's just an accumulation of simple concepts. Once you can get the simple concepts, you are good. Okay? It's not magic, they're quite simple concepts. Okay? Hello? Uh, okay. Aside using the volumetric system, we can use the grams to kilograms and all those guys. So we can use that. Okay. We'll do that in just a second. Let me just explain this. This will give us enough explanations to run through. Now let's see. Gallon. How do you make a gallon? How many quarts make a gallon? How many quarts make a gallon? That should be four. Looking at the diagram. Below, are we together? Quarts make a gallon. That should be gallon. Quarts for a gallon. So basically, what you do is to quarts. And so let's see how many cups make up a quart. Four cups. 4 cups make up a quart. Yeah, 4 cups equals 1 quart. Okay. That should be the multiplication. And finally, gallon itself. Type gallon for method receiver is gallon. And so you can say gallon of quarts is quarts 24. Yeah. You can see there percent many gallons? Percent. Passing. Oh, what we passing now? Out of that, comma. Right. We have the first part done. Are we there? Good. So let's start to explain it based on what we talked about earlier. So we have an ounce. You can have the image open anywhere you want, just you can see it. Are we together, please? We can have the image open. Let me share my full screen. So I'll just open this image once and for all. Guys, stay with me, please. Entire screen here. Okay, this is where I got the image from. Can you all see my screen? Can see my Google Chrome? Yeah, this is where I got the image from, basically, that I'm going to be using to explain. This is where I copied it from, so I just did a copy image and then pasted it on the Slack channel. Yeah, so we're trying to build like a conversion system to see how things are made up of other things. And awesome. You can see the smallest unit of everything is cups. Please follow me, guys. This is very interesting. It's very, very interesting. Now, a cup, 4 cups make up 1 quart. Okay? 4 cups make up 1 quart. And then 16 cups make up 1 gallon. So that means 4 quarts make up what? 1 gallon. Are we together? Are we together? So that's like the first place we are starting from. And then let's now see the interpretation of what we just said or what we just saw in our code. So 4 cups make up 1 quart. Just 4 cups. Now 16 cups make up what? 1 gallon. Are we together? There's still smaller ones like tablespoons. These are ounces that was the first. But note this guy. Note this first one. Now let's go back to the code. This is a cup. We created a type of what? A type cup. Are we together? Now, what are the like methods on a cup? A cup is like 4 cups. One. Okay. And so if you say cup dot quart, for instance, you are trying to convert what a cup is to equivalent of quart. You can see what we are doing here. What we are saying here is that you are taking in a quart. A quart is this container that we saw. Which is like I think is 1/4, yeah. And basically it takes four cups to make up one of these. So if we are on cup and we want to get what the equivalent quart is for a cup, it will be that cup divided by 4. 0.25 is 4 is 1 divided by 4. Okay. Now let me go to another one. Yeah, this one that actually makes sense with it, actually. This one that makes sense with it. So we are going to start from quart now again. This guy. To make up one of this guy, we need what? We need four types of four quantities of cup, four volumes of cup. Am I connecting with you guys at all? Is this really connecting? I'm trying to explain how you can use methods on like in OOP to formulate different kind of things. Now we've created an object of type gallon. We created an object of type quarts. We created an object of type cup, and another one of type ounce. Okay. Now 1 gallon is what? 4 quarts. Okay, are we together? 1 gallon is 4 quarts. That's why we have G times 4 here by this guy that we have here. Now, that is, it takes 4 quarts to make up a gallon. Now, let me expatiate on it. Now, when we're talking in some previous classes when we're talking about functions, we told you we discussed that some functions will return a particular type, right? Some functions can return a particular type. Now, you will see that even the methods too, because we've implemented them as methods, doesn't mean that they won't be taking any type again. They can still take the type that they want to be returned. Are we together? So basically, if I take a gallon, or if I take let's come back to this one. This one is better. This is the first one we're looking at. If I take a quart, for instance, and I take a cup of it on it, or if I want to formulate a cup from it, it should return a type cup to me. That's what this type is saying. When we type functions, functions can return int, or what? Or float, or what? Or string, or even multiple parameters. Are we together? So here on the quart type, on the quart volume, if I call the function cup, I want to return what? I want to return type of cup. I don't know if this is making sense actually. Please don't just say yes. I'm ready to go over. I know it's a very its concept might be weird, but I'm ready to go over and over it again for us to understand. I just want us to understand how you can attach methods to types. It's not, and this is one thing I just looked up and came up with that seems to implement it well. But looking at it now, I think we need another example to explain this better. But follow me closely. I'm willing to explain it as many times as it will take for everybody here to understand. Okay? Now, a quart is a container that is made up of what? That is made up of 4 cups. Now, if I want to convert a cup, because this is like a conversion system now. Sorry, 1 second. So this is the conversion system. We are converting cup to quarts, quarts to gallon, and all those kind of things. So if I take a quart and I want to convert it to cups, what will I do to it? I'll multiply it by what? By 4. Is that one simple enough? I feel that should be simple enough. If I take one container, which is a quart, this guy, and I want to convert it to cups, what will I do to it? I'll just say quart dot cups, right? and it will be converted to what? To cups for me. That's what this function is doing. I want to convert it to cups. If I take a quart and I want to convert it to gallons, how many gallons make up? How many quarts make up a gallon? Let's see again. 4. 4 quarts make up 1 gallon. So that is, if I want to convert a quart to gallon, what will I do? I will divide it by what? By 4. Because, do you agree? Should we use the kilogram system now? I think we should use kilograms now. Yeah, the return values are typecasted. Now, okay, nice one. Let me just stay with you on that point. I want to convert quart. This is a conversion system. So let me label it at the top. Simple conversion system. That's why STPN. Metric conversions we have there again, but that can be easier for us to relate with. Which other one do we have there? Maybe we should look at that and implement that. But Akinsoya, nice question, nice point there. Come back to quart again. I have a quart and I want to convert it to gallons. Let's say I want to pour it inside a gallon, for instance. How much of that quart will I pour into a gallon? I can't pour. If I pour everything, it won't fill up the gallon. Will it fill up the gallon? No. It will only fill up what? 1/4 of the gallon. So to convert a quart to gallon, it is that quart divided by 4. So what we can do here, another way to do this is say divided by 4. I don't confuse us too much. So a quart is 1/4 of a gallon. Okay. And then because we have converted it to gallon, the type will now be what? Type what? Type gallon. That's why the type is now type gallon. Do you get the logic now? Do you get the logic now? I converted, it's a conversion system. So basically we are converting volumes from different containers to another. And then we took a quart and we try to convert it to a gallon. If you try to convert it to a gallon, it means it's going to return 1/4 of what is in that gallon. So it is what? Gallon. And you see that because gallon is one of the conversions of quart, okay, we attach it to it by doing this. Please, are we together, guys? We attach it to quart by doing this. What do you call? Cups can also be converted to gallon. In fact, we are going to do that as an example now. We are going to convert cups to gallon. Do you get it? But understand quart. Understand this one I'm doing now. We're converting the quart to gallon. And from the image we have, 4 quarts, look at it here. 4 quarts make up 1 gallon. So if I want to convert 1 quart to a gallon, it will be that quart divided by 4. Now, there's something interesting here you have to know. Because I passed in the receiver here. Note, this guy is called the receiver. Because I passed it in here, whenever I call this guy, whenever I call quart, okay, whenever I call quart, whatever I pass to it will become Q here. Are you feeling me? Let's comment this out and start with our quart example. Okay, I can create different quarts now. Look at the concept of what will be coming to play here now. So quart, quart 1 equals to what? Quart what? Let's say 1. We want to make, we have 1 quart. Now, quart 2. This This guy and this guy are totally different, despite the fact that what they are implementing the same blueprint. This is the Quartz blueprint now. Do you get it? You get it now? Can you see this? I can be able to see the similarities between this guy that we have done and the class that we talked about earlier. Now, I passed in one to this first guy. Please follow me. I know the concepts might be tricky. We're still going to talk about it in our next class and 2 more classes just to get this concept. I passed one to this guy. Now, let's go and look at the definition of Quartz. Look at the definition of Quartz here. Okay. I have passed it to, I have passed one to it. So Q, anywhere you see receiver function that is taking the type of Quartz, Q there will be what? Will be 1. Are we together? Now we have just instantiated a new object. This is an object. You can say Quartz is an object. And remember, in the example before this one, I said to access this is Quartz now. What are the methods we have on Quartz, please, guys? We only have gallon and cup, right? These are the 2 methods that are taking the Quartz signature, are taking the Quartz receiver. I really want us to get this concept. It is really, really interesting and really, really important. Now, these are the 2 guys, just gallon and cup, that are taking the Quartz receiver. And so, to be able to call them, anybody that was created by initializing Quartz has access to just those two methods. Are we together? So fmt dot print line Quartz. Okay. And let's do the same thing for Quartz 2. So what I'm going to do now to make the concept even more simpler is that I'm going to take out this guy. Because I can't get enough. I don't like the responses I'm getting in the room, so I'm trying to make it much more simpler, and then we'll build it to be more complex from there. So let me take out everything here and just return simple things. But yeah, so this won't be gallon anymore. This will be a fluid 64 now. Okay, and then I won't look at the casting again. That's what I did there. I'll just cast it to fluid 64. And yeah, I think we'll build on top of this instead of pushing the whole example to it and rushing it. From here, okay. So I'm going to take out all of these too. Simple conversion system. Okay. Let me look at kilogram. Find anything. But if anyone finds any conversion example we can use, maybe we implement that so everybody can understand. But let's come back to what we have to work with. This is like the only thing we have to work with for now. But is everyone in the room Nigerian? I don't know if you could just use that degree. I think everyone here is Nigerian, right? I'm assuming I don't need the assumption. So we can use maybe like the Naira and Kobo explanation. Hello guys, it seems everybody went to party today. People are just on this call, barely interacting. Saturday classes are less interactive than the midweek classes. I don't know why. And everyone still hear me. Okay, I got 1 years, 2 years is that's 3, 4. Let's see. Where is every other person? 5. On that channel, we are actually more than the number we're waiting on this class. 6. Okay. Uh-huh. So I know I was saying is majority of us Nigerians, so we can use the naira and kobo conversion system. Maybe that will resonate better. Or this one is okay. We can continue with this one. So do we use naira and kobo or do we use this volume conversion system? Let's switch to currency, okay? Okay, let's use naira and kobo, or we should use dollars. Let me see. Dollar conversion system. What an example that would resonate. Cent to So we don't know who else might be watching the video. That's why I want to do something that will know global. Come on, come on. Okay. Let's do something that will know global. Okay, maybe if you use Naira and Kobo, just label it properly so that everyone gets it. Ask it to find something. Because why I went for this volumetric, the volumetric seems to have enough things to convert to actually. Naira and Kobo now we can only convert Naira and Kobo. That's it. Do you get it? But volume now, you can see that we can convert from quart to gallon. From gallon, you can convert back to cups. From cups, you can convert back to ounces. Those kind of things we bring out the ideology of what we are trying to explain here. Let me just continue with this. If you have any question, feel free to ask me. I will reply there. So going back to this image. Okay, meters, centimeters, millimeters. Okay, let's see that. What as centimeters, millimeters? Yeah, chat. Okay, yeah, that's another perfect one. Let's see. For the images. Let's chat that looks correct properly. I like the idea, Francis. Could you look for an image for us to use the conversion so that we know everybody can see as we are making the conversions from centimeters, meters. Let me see. Length converter. Okay, length converter is here. Let's see. Aha, this one makes sense. This makes sense. Meters, centimeters, millimeters. Awesome. What is this? Let's do it on Slack. So we'll start with the metric conversions and we'll work our way up to standard conversions. Note, we are only just these are just we're just explaining OOP methods for now. We have not really dived deep into OOP. So let's use another one. Sorry guys, I'll just delete this maybe. Yeah, I'll just leave it. Let me just leave it. Start here. What's this guy doing? Come on. Come on, come on, do that. Let's see what we have. Okay. Let's go. So 1 centimeter equals to 10 millimeters. Look at everything here. Awesome. So centimeter. So we can start with a type of what? A type of type centimeters. Should be like a unit. A float there. No float for now. Okay. Type centimeters. And centimeters can be converted to what? Centimeters can be converted to what? Millimeters, right? So in that vein, we can have a what? We can have a millimeter method. Okay? That will give us anything we pass to centimeters. It will give us the millimeter conversion. Do you get that? So function millimeter. Okay. Let's say unit 2 for now. Sure. Yeah. Passing the receiver function now, it receives a type of what? C centimeter. Now, an idiomatic way, an idiom in Go is to always make sure that when you have declared a type, how do I person this? Let me just share this. Thank you guys for the suggestion to a more simpler, relatable. Okay, Gideon, you're welcome. This first time I'm seeing you. Nice to have you. Take all this out. All this out. Okay, now in Go, the idiomatic way of writing it, of writing a receiver function, is to make sure that when you define it, you know this is the actual variable and this is the type. Normally in our normal function definition, if this I was going to take some values now, it will take, let's say it want to take some values, it take x and that's integer. You get it? This was when we were doing functions, when we were defining functions to accept parameters, right? This was so the same thing happens in receiver functions too. You have the receiver itself and you have the type. So to label your receiver, it is always the first letter of what of the base type. So this is centimeters. I did C. If you look at other examples I've done in the past, you will see that I use that idiomatic way instantly. So take note of that. That's something you should take note of. What am I doing now? Sorry. I just wanted to show you what I did in those previous places. Okay. Instead of doing that, I can go to my local history here, show you history of this file. I can see it. Let's see. Places where I did all those stuff. You can see when I did ounce here, and I wanted to pass a receiver function to ounce. Look at it, func. So this is type ounce. When I wanted to define a receiver method, I just did O ounce. You can do O ounce or OU, anyone, but it's always one or the first letter or the first two letters. Okay. Look at type of cup to type cup. C cup. That's it. I have another type that starts with C. You know, for that other one now, I will now use the first two letters of it. So just take note of that. Just take note of that. It's a minor thing I want to point out. So U in C. Now this will return what? How many millimeters make up a centimeter? So that will be return unit of what? And this one can even you have to this has to be float actually, because when you do the division, it won't work. Because remember, you are going from centimeters to millimeter, so it's going to be higher. I don't know if you understand what I'm saying. It's going to always be higher. Okay, so basically, this is going to return a float. Let's keep it at float. So float 64. 32, 64 is too big. 32. And then it is C divided by what? 10. Awesome. Please, I'll really love if you guys follow me. I know it's a very tricky concept, but this is it. This is just it. 1 centimeter makes 10 millimeters. Okay. It's divided by 10. Let's go back and see that. Is it divided by 10? It should be multiplied by 10, sorry. Not divided by. Multiplied by 10. Centimeter is the greater guy. What is this? The centimeter is the greater guy because it takes 10 millimeters to make just one centimeter. So the centimeter is the greater guy. And then if you want to convert a greater guy, if you want to convert somebody that is the greater guy to the smaller guy, you have to keep multiplying the smaller guy's units. Okay? Do we get that? If you want to do type of millimeter now, millimeter, yeah. Sorry, this is from this type. Okay. Okay. So centimeter now. Centimeter. Okay. And now we want to convert a millimeter to centimeter. That's where we what? That's where we divide. So we turn 32 of what? A millimeter divided by what? Are we together? Look at that chart again. 1 centimeter equals to 10 millimeters. So 1 millimeter will be what? Will be 1 over 10 centimeters. So you want to convert millimeter to centimeter. So the smaller guy to the bigger guy. So it will be divided by, by 10. Do we get that now? So now let's play around with these two guys. So we converted millimeter to centimeter. And we're converting centimeter to what? To millimeter. Okay. So let's say length, LENGTH, length 1 equals to what? Let's start with delimiter of 10. Okay, fmt.println length 1 dot what convert is what centimeter now. What will it give us? We should be getting millimeter to centimeter, millimeter to centimeter. We should be getting 1. Mm-hmm. Main dot go. So main dot go. Go volume. Yeah, 1. 1 millimeter makes 1 single centimeter. Okay, that's why we're getting 1. Let's say we now have 5, let's say, or we have 2 millimeters. What is if you want to convert 2 millimeters to centimeter, what will it be? Run it again. Okay, because I int this. So I can take this guy. And why is it 0? Millimeter 2 divided by 10. Float. From 0, right, 0. Centimeter. This is 2 divided by 10. It is 0 point something, but why is it not stringed as something? 0.2. Okay. Remember, this guy is coming, so. Meter to centimeter. Transferring that method. The new line here. Still not giving me the full. That's what I'm looking for. But if you convert 20 now, or 200. Oh, sorry. It should have given me the right amount. But the parent type is the one cutting off, giving us. Are we together? Yeah, it should be float. Yeah. So the parent type is the one cutting it off. I didn't know I didn't do it as float. So float. Float 32. Here and here. Okay. Again, converting 0.2. Awesome. So, thanks for this very simple example that everyone can relate to. We can use this to build up on bigger ones. So, we created a type of millimeter. We can create another length 2. This is what I talked about when I said blueprint. Okay, you can create any amount of object from a particular blueprint that you want, and they are not related to each other. They won't affect each other. They are 2 different instances as you see them. Just the way we created vehicle and then automobile, and then from automobile we created Toyota, we created Honda. They all have the same properties, but they are not affecting each other. Okay. Now, same thing you can do here too. Length, we call it length 2. and 2. And then if I run this again, you'll see that they are totally different from each other. Despite the fact that they have the same, they have the same. The blueprint was just something like, it's just like what architects draw when they draw the plan of a house. Okay? The fact that you use that plan to build one house doesn't mean you can't use it to build another separate house again. So that's what's going on here. We created a blueprint of what type millimeter, and we created two different lengths from it. Millimeter that is of length 2 and millimeter of length, of length 90. And we try to convert them to centimeters individually. So one gave us 0.2 and the other one gave us 9 centimeters. Are we together? You get the logic now. So that's basically it. We can also create a blueprint of, so now this is where it gets interesting. The value you use to instantiate, this is instantiation. The value you use to instantiate your own type of that blueprint, it is that same value it will carry when it's calling any method or any function of it. Okay, we used 2 here. So when we got here, when we got to the centimeter function, inside the centimeter function, the value that we passed into it revealed itself. So 2 came here. The value from the base, from the receiver method, it became 2 here. That's why we have access to it here. Are we together? Is that simple enough? Okay. Is that simple enough, please? Yeah. So, let's see. Come here. Sorry. Yeah, I see new names once in a while. I'm always surprised. So I always try to look up who the person is. So that's what's happening here. There is no magic going on anywhere. Because we used this guy, whatever we passed in to it when we are instantiating it, that is what it will carry for as long as it has to run. Now that we have, so we get that right. Now let's now see how we can convert back. We have converted something to centimeter now using this. There are ways to also, okay, if you see a language, if you see other languages where they talk about this, some people use this dot, all value, and this dot method. In Golang, this is our own this. We don't have any other keyword for it. So there are very few keywords to even master in Golang for you to be proficient at it. So we don't have things like this, we don't have extents, we don't have implements, we don't have all those wide range OOP stuff. So if you want to attach a method to a type, this is how you do it. Basically just passing a receiver function to it. Look at our normal function definition here. That's already there. And then this is the receiver definition. This receiver also receives pointers too, but we'll talk about that in the next class. Time has gone. Let me quickly brush over what I was about to talk about here. So as we have converted from centimeter now, we can also convert it back to millimeter again. So this is centimeter, and let's see, centimeter. So you can update the type. Are we together? You can update the type. This is type float now. Millimeter is also a type, right? Centimeter is also a type. So if I'm converting something to centimeter, definitely the type should be what? What should the type be? Hello? If I'm converting I'm converting millimeter to centimeter, what should the type be? I'm converting millimeter to centimeter. What should the type be? The type should be centimeter actually, because the value is giving me is no longer in millimeter, it is now in centimeter. I don't know if you understand that, if you get that. Do you get why it's in centimeter? Because I'm converting to a particular type. I mean, it's just like you want to travel from your country to another country. You need to have something that identifies you as. You need to have like a maybe like a passport or visa or something like that. So I'm converting from millimeter. I said length 1 dot centimeter. That's converted to centimeter. So the type, what it should return to me, should be type of what? Centimeter. Are we together? So centimeter, let's see, let's update this one too. So centimeter, I pass it in here. That return the type of what? Centimeter to me. And you can see our compiler is instantly throwing a red line for me because float 32, type of float 32 and type of centimeter, they are not the same thing. Are we together? They are not the same thing. That's why it's throwing an error. So if I said my function is going to return a type of centimeter, then my values will also be in centimeter. So I convert it back to centimeter. Are we together? And now if I run the function again, everything still works. Okay. But as I have run this guy, as I've told you, as I've told my compiler that okay, what I'm returning is a type of centimeter now. It also means that all the methods that are on type centimeter, I can call them on whatever I've returned, because what I returned is a type of centimeter. So every method, these are centimeters method. Every method that is on centimeter, I can call them on whatever I return. Are you getting the trick now? Let's quickly be blend one last one and then go. So centimeters to meters. So that is centimeter can have what? Meter. So this is centimeter. That's okay. Let's take that float. 2 for now. I'll return. We don't have a type meter, so we can create a type meter for instance. Quickly type meter can be also float. Okay. So this is converting centimeter to meter. I hope we are really getting this really. What will it be to meter? 1 centimeter and convert 1 centimeter to meter. What will it be from the conversion chart? It will be divided by 100. Because it takes 100 of this guy to make up. It takes 100 of centimeter to make up 1 meter. So if you are taking a centimeter and converting it to meter, divide by 100. Okay, at least that's 32 for now. Guys, are we still with me? Sorry, I'm going to let us go now. So I just wanted to point out how we can convert from millimeter to centimeter and centimeter to meters. You see that? So we first created millimeter, we converted the centimeter, and we made sure that the type we are returning is type of centimeter. Okay, we made sure of that because we want to call other methods that only exist on centimeter type, like the centimeter instance or object. They don't exist on this is type millimeter now. If I do dots, the only thing you can have access to, the only methods on millimeter are centimeter. You get that? Now, but if I come to centimeter here and I do dots, you can see that I now have 2 methods. And I have those 2 methods because I have changed the type. I changed when I was in millimeter, I changed the type that I'm expecting. Float 32. If I put it back at float 32 now, and I come back here and I do dot. It's just giving me the normal methods that are available on that standard type. It's not giving me the methods that I need that are on centimeter. I don't know if you get that. These are the methods on centimeter that I need, millimeter and meters. It's not giving me access to those methods because the type that I return is not type of what? It's not type of centimeter. So I go back, change it, centimeter. Now I have access to what? I have access to meters and millimeter. So I can convert it back to millimeter, for instance. I convert that first leg back to millimeter. I should be getting my value of what? My value of 2 back. We currently have 0.2. But if I convert it back now, let's see. Yeah, I get my 2 back. Do you get it? Because I have access to millimeter method on centimeter class. If I convert it to meters, what would it give me? Yeah. So converting 2 millimeter to meters, it is 0.002 meters. Okay. See you guys in the next class. Thank you so much for. Yes, we are running with the value. I just did that. Can you run what's the value, Francis? Sorry. Can you run what's the value? Let me be sure I got your question right. Yeah, Francis, can we run what with the value? We just did. What should you run with the value? That's what I'm asking. We'll go deeper on it in next class. Maybe post your questions to me on Slack, following everything you saw here, and then that's the question earlier. Okay. Before I did the example, right? Okay, okay, okay. So one more thing you should note here, very quickly, as we have returned from length to centimeter, as we returned type of centimeter, what we are instantiating centimeter width now is the value of this computation. That's what centimeter will be. So inside the methods of centimeter, C here and C here is whatever the outcome of this computation is. And that's how you keep passing states to every object in the class, and you keep updating the state of everything. So that's it, guys. I'll go deeper in next class. Please watch this video as many times as you can. Bring in plenty questions in the next class. We are really going to go deep. We'll now, using this that we have covered now, we can now go back to the automobile or the proper way of doing classes, which are like using structs and all those kind of things. Thank you so much. I took a bit of our time today. Thanks, guys. See you on Wednesday.